Welcome back, everybody. We're going to start our final unit of the year, which is geometry. After this, we're really just going to review everything we've covered and make sure that your portfolios are all set for the final. So, why don't we get started? In order to understand geometry, it's important to understand the terms that we use. So the vocabulary that we have in order to make sense of everything that we're talking about. So geometry is the study of space. It's the way that we make sense of space mathematically. And in order to do that, we have a couple terms that we use just to identify certain parts of our space. So the first one we're going to talk about is a point. Everything we do in geometry is based off of the idea of a point being location. So if you've ever, let's say, gone to the mall and you've been walking around and maybe you got lost and you saw one of those information desks that says you are here. There's usually a point on the map that says you are here. Well, if you look down underneath you, you won't see a large point where it says you are here right next to it. The point on the map is just an idea of where you're standing. It's a location. And that's all a point is in geometry. It's a location. It has no size or shape. It's just acknowledging the existence of this one particular spot. So the way you'll see a point written is exactly the way you would expect. It looks just like that. And the way we label it is we will use a letter, like A, for instance, to say that that's point A. And that's all we would do. So if we had multiple points, we could then do some things with them. An example of which is a line. Now for any 2 points that you have, there's only one line that can go through it. So for instance, if I had point A and I had point B, if I did that, that would be a line. What a line is a collection of points. So these aren't the only 2 points on the line, but they're the only 2 we're listing. It's a collection of points that extends infinitely in 2 opposite directions. So in order to name a line, you can pick any 2 points that are on it and write them next to each other like this. And then you're going to put a line above it with an arrow on either side. And that lets us know that these 2 points are on this line and the line goes on forever in both directions. So that's what a line is. The next term we're going to talk about is a line segment. Now the reason line segments are important is because you can't measure a line, because lines go on forever. But you can measure a part of a line. And that's all a line segment is. It's a part of a line. It's going to start and stop at 2 endpoints. So if we had the same line from above, and we had A, and we had B, and you just wanted to measure from here to there, you could. You'd be looking at a line segment. And that's an example of a line segment. So it starts and stops at 2 distinct endpoints. You could measure it. I could tell you exactly how long that is. I could take out a ruler and measure it. That's what a line segment is. The way we write a line segment is just like writing a line. We write the 2 points down next to each other. You put a bar over the top, and then that's it. There's no arrows, no nothing. It's just a bar. And that's all you would do. So that's a line segment. A ray is sort of halfway in between. It's going to stop on one end, but it's going to go on forever in the other. So a ray, let's say we started at point A, and we continued forever in the other direction. We passed through point B, but we kept going. That's an example of a ray. And the way we would write a ray is we would write A and then B, and then we would draw an arrow from left to right. Now the important thing with a ray, with a line or a line segment, I could write BA, it would still be this line. I could write BA here, it would still be that line segment. But for a ray, the first letter you list has to be the endpoint, and the second letter you list is going to be the point that it's passing through. You have to keep that in mind, because if you wrote it the other way, it would mean we'd start at B and go past A forever, but that's not what this is doing. It's going the opposite direction. And also, because we read left to right, we always put the arrow from left to right, so that we know where our endpoint is and where we're passing through, no matter what direction the ray is going in. So those are a couple terms you're going to need to know right away. But there's some other terms that are going to be important. The next one is angle. Now an angle, if you can imagine a ray like this, and then another ray like that, coming out of the same point. So let's say we had ray AB and we had ray AC. So we have two rays that start at the same endpoint. That's going to form an angle. This distance in between is what we refer to as an angle. It's measured in degrees. So if you've ever heard of a 90-degree angle, what that's referring to is an angle that's exactly 90 degrees. And it's very useful because that's how you would typically build anything. If you want to make it square or rectangular, like the room that we're currently in, you want to use 90-degree angles. So it's important to know what an angle is, how it measures, and what exactly it has to do with how your world is around you. So this is an angle. We can write the name of an angle many ways. In order to do it, it's important to understand the parts of an angle, mainly that point right there, the point that both rays start at, where they're continuing, like the elbow of the angle here. We refer to this as the vertex. Now, if we want to write the name of an angle, if I had the angle labeled, like if I called this angle 1, I could do that. That's a good name for an angle. You'll notice this slanty L looking thing, that's our symbol for angle. You might also see it with a curve inside like that. They mean the same thing. So if you see it one way or the other, they both mean the same thing. So we have angle 1. You could write angle A as long as it's the only angle coming from that vertex. So we could write angle A for this, but if we had another angle coming out, we couldn't call it angle A anymore because there's multiple angles coming from that vertex. So the other ways we can name this, if it wasn't labeled and if there were multiple angles coming from the vertex, is we would use 3 points. We would use a point on one of the rays, we would use a point on the other one of the rays, and we would use the vertex. And this is the most important part. You have to make sure that the vertex is the middle letter that you use. So you could call this angle BAC, or you could call this angle CAB. Because the vertex is the middle point that we listed. We cannot name it angle BCA because it would mean BCA. It would mean the angle that would be formed over here, not this location. So that's why it's important, so that we can tell them apart. That's how we name angles. Now there's some other things we can do with angles. We can classify angles. So for instance, angles, they're large, they're small, they're in between, they're all over. So we have certain names to classify the relative size of an angle. There's more than just what's listed, but this is what you're going to be responsible for. So acute angles, or any angles less than 90 degrees. So 90 degrees, what that is what's known as a right angle. So if it's exactly 90 degrees, it's a right angle. What that's going to look like is, just imagine a square in your head, or you could just look at the one I drew there. You'll notice how this side and that side, they form this box, right? So that's a 90-degree angle. This distance from here to there is a 90-degree angle. If this angle got any smaller, it would be what's known as an acute angle. If it got any larger, so that it was more space like this, that would be obtuse. So an example of an acute angle is like this. It's less than 90 degrees. You can imagine 90 degrees was right there. It's smaller than that. A right angle is exactly 90 degrees. The way you can tell is you'll see this little box. That'll let you know it's exactly 90. We would refer to the lines that form a 90-degree angle as being perpendicular. It means it's forming a right angle. So if you ever hear that term, that's what we're referring to. And then the final angle relationship that we just mentioned a minute ago is obtuse. And what that means is it's going to be larger than 90 degrees. So you can imagine a 90-degree angle, and then if we kept going and went further, that would be obtuse. So it's greater than 90 degrees. There's some other names we use, but for you guys, this is going to be all that you're responsible for. So make sure you understand what they mean. Now there's a couple other terms you might see along the way. Complementary. Those are angles that add to 90 degrees. So if you had two angles, for instance, if you had this angle here and then you made a second angle there, these two angles would end up being complementary. They would add to 90 degrees. They don't have to be next to each other like this. Typically you'll see them that way, but they don't have to be. It could be a 30-degree angle here and a 60-degree angle there, and they're going to still be considered complementary. Supplementary is the idea that two angles add to 180 degrees. So here's one angle here, and if we had another angle here, and the two of them added to 180 degrees, that would make them supplementary. Again, they don't need to be adjacent, which means that they're sharing a side here. They don't need to be that. We could have an angle that's 100 degrees over here and an angle that's 80 degrees over there, and that would still make 180 degrees. That would still make them supplementary even if they're not touching. And then the final word that you're going to need to know before we go through the angle relationships that we talk about is going to be congruent, right? Congruent, it doesn't necessarily mean equal. It's a slight difference to that, but for what you need to know, you can think of being congruent as being equal. The symbol for congruent actually looks like an equal sign. So here's the symbol for an equal sign. Congruent, you're just going to put a curved line up above it like that. That's a symbol for congruent. So if you see that symbol, it just means two things are the same exact size. So their measures are equal. So I'm going to quickly tilt the camera. We're going to talk about angle relationships, and then that'll be it. Okay. So the final thing I'm going to expect you guys to be able to do when I get back is to understand angle relationships. So what you'll notice here, I've drawn two lines, and they're going to be what we refer to as being parallel. It means that the lines are going in the same exact direction. They're never going to touch. They're always going to be the same distance apart, like railroad tracks, the two metal steel rails that go the entire way, not the planks that cut across them, but the two steel rails. They're always the same distance apart, and they're always going in the same direction. So think about those parallel lines like that. And then this line over here is going to be what we refer to as the transversal line. What that means is that we're cutting across these two parallel lines, and when we do that, you'll notice that we form all of these angles. So you can imagine if this was a vertex, we could have a ray going this way and a ray going that way, same thing here and there. So what we're going to have is we're going to have 4 angles form up top, we're going to have 4 angles form down below for a total of 8 angles. You could see multiple examples of this, so if I added a third line, we'd have another 4 angles. I could add another transversal going the other way, we'd have even more angles. You can add as many as you want, but for now, just to keep things simple, we're going to focus on these 8 angles. And we're going to talk about the relationships that form from them. So the first angle relationship we're going to talk about is one where they're congruent, and that's vertical angles. Vertical angles are like scissors. So if you can imagine when you're cutting with scissors, how when you go to open the scissors, the top part opens up here, but the bottom part does as well. And when you close them, the same thing happens. The top part closes, the bottom part closes, and the two side parts, you'll notice, will do the same thing. So what vertical angles are, when we have two lines intersect, the two angles that are across from one another, like angle 1 and angle 4 over here, or like angle 2 and angle 3 over there, are going to be what's known as vertical angles. And I'm just going to put in parentheses over here 1 and 4, just so that you guys know that those are two. That's an example of the two angles that would form vertical angles, that would be considered vertical angles. The reason that's important is because no matter how big or small this angle gets, I always know 4 is going to be the same exact size as angle 1. Always, always, always. And that's why these rules are going to be important. Because no matter how these angles change, I know these rules will be in place as long as these lines are still parallel. So that's an example of vertical angles. The next example I'm going to show you is a linear pair. This is an example of two angles that are supplementary. That means they're going to add to 180 degrees. So, linear pair, think about the name, linear, so straight line, pair, 2. We're going to have two angles that are on the same side of the straight line, and they're going to be adjacent to one another, so that means they're going to be next to one another. So these two angles over here, angle 1 and angle 2, you'll notice they're on the same side of a straight line, and they're next to one another. They share a leg, or they share a side. So when you do that, you're going to have both of these angles add to 180 degrees every time. The reason for that is all the degrees around one particular point is 360. That's why if you spin in a circle, it's considered a 360, because you're spinning around and facing the same direction you started with. But we're not looking at an entire circle, we're looking at half of one. So half of 360 is 180. So we know these two angles have to add to 180 because this is a straight line. And it doesn't just work for 1 and 2. We could have done the same thing with 1 and 3. Because we could have used this straight line. We could have done the same thing with 2 and 4. Or some of the angles down below. They'd work the same exact way. But that's an example right there of a linear pair. So we have a straight line, and we have a pair of angles coming from the same vertex on that straight line. And it doesn't matter what you do with the direction that it's going to go, you're going to notice that the two angles that are formed are always going to add up to 180. So that's the second relationship, and I'm just going to write 1 and 2 over here just so you remember the relationship. It's not the only linear pair here, but that's the relationship we're looking for when they're on the same side of the straight line like that. The next one we're going to talk about is alternate interior angles. So we're going to think about two words here, alternate and interior. Alternate is going to mean on opposite sides of the transversal line. Interior is going to mean on the inside of the two parallel lines. So an example of alternate interior angles would be like angle 3 and angle 6. You'll notice angle 3 and angle 6 are on opposite sides of the transversal line, but they're also both inside the two parallel lines. And they're going to always be congruent. So this is kind of like scaffolding. If you've ever seen somebody build scaffolding and they've got those crosses in between, you can imagine if they went up or they went down, that both angles would grow and shrink. So if you think you have a platform, you have another platform, you have a couple of beams going across to support it. If you wanted to raise this up like this, so here's your two platforms again, but you've raised it up, what you're going to notice is this angle and that angle will be the same size, whether it's condensed down like that or whether it's expanded out like that. So that's the idea behind an alternate interior angle, is they're always going to be the same exact size, they're on opposite sides of the transversal line, and they're both on the inside of the parallel lines. And an example of that would be 3 and 6. The next angle relationship we're going to talk about is alternate exterior angles. Same idea. We're going to be on alternate sides of the transversal, only this time we're talking exterior. So it's going to mean outside, which means we're going to be on the outside of the two parallel lines this time. So alternate exterior angles, if we had angle 1, for instance, we want to be on the outside of the parallel lines. So if we look on the other side, we're on the outside of the parallel lines. It's either 7 or 8. And we want to be on the opposite side of the transversal, which means the angle that it's going to be an alternate exterior angle with is going to be angle 8. So what you'll notice here is angle 1 and angle 8 will be the same exact size every time. For the same reason the alternate interior angles work, alternate exterior angles will work the same way. But what you're going to notice is they're always going to be congruent, and you're going to notice they're always on the outside of the two parallel lines, and they're on opposite sides of the transversal. So that's alternate exterior angles. And an example of that is 1 and 8, but an example could also be 2 and 7. So it's not just that example. We could have multiple examples. So that's alternate exterior angles. The final one we're going to talk about as far as being congruent is going to be corresponding angles. So with corresponding angles, what I want you to do is I want you to look at the 4 angles up top over here, angles 1 through 4. And I want you to imagine what would happen if we took those 4 angles and we moved them and slid them on top of angles 5 through 8. If we did that, does everybody see how angles 1 through 4 are going to match up with where 5 through 8 are? So there's 1 through 4, we just slid them down, and now we have 5 through 8. You'll notice that 1 is in the same location as 5. You'll notice 2 is in the same location as 6. You'll notice that 3 is in the same location as 7. You'll notice 4 is in the same location as 8. What we consider those to be is corresponding. And the reason is, the angle relationships of these 4 angles here will correspond to these 4 angles there. And what we want to do is we want to find which angles are in the same location relative to one another. So if angle 1's in the top left corner, so is angle 5, they correspond to one another. So angles 1 and 5. But 2 and 6 would work, 3 and 7 would work, 4 and 8 would work. They're all corresponding. So you just want to find which angle matches up with the other angle that I'm looking at. And if you can do that, you'll get the right answer. So that's corresponding angles. The final angle relationship we're going to talk about is same side interior angles. Again, we're going to use the names of these angles in order to figure out what they mean. So in the same way we used alternate interior and alternate exterior angles, we used the names to figure out what exactly was going on with the relationship. we're going to do the same thing with same side interior angles. So same side interior angles, we're going to be on the same side of the transversal line. So let's say the right side in this case. And we're also going to both be on the inside of the two parallel lines. So if you took a look at angles 6 and angles 4, they're going to be, and I'll write it in red so it matches everything else. That's going to be an example of same side interior angles. They're going to add up to 180 degrees every time. The reason is, if you think about corresponding angles, if I took these 4 angles and put them up top over here, angles 2 and 4 would add up to 180 degrees. So would angles 6 and 4. So you could think of them almost like linear pairs if we had slid them up or slid them down. So that's why same side interior angles are going to add up to 180 degrees. It's going to be based on the angle relationships we know. We can use any of these angle relationships to prove why the others will work. They're kind of all based on the same idea. But that's the idea with angle relationships. Sometimes you're going to be asked to solve a problem like this, where you have a transversal line and 2 parallel lines, and I tell you that this is 110 degrees. And I ask you to find how big are the other angles. Well, you would know, well, these are a linear pair, so that's going to be 70. These are vertical angles, that'll be 70. These are vertical angles, that'll be 110. And then I can take these 4 and put them down in the same location, and I can solve it that way. You're going to be asked other times to solve for a transversal, or to solve for angle relationships using a transversal, where you're going to have to solve for x. So here's your transversal line, here's your parallel lines. If I told you that this was 3x and I told you that this was 120, we would know that they're alternate exterior angles. They're on opposite sides of the transversal. They're both outside the parallel lines, so I know they're going to be congruent. And if I know that, I would take the 3x, I would take the 120, and all I would do is just solve for x. I know they equal each other because they're the same exact size. That's what congruent's going to mean. And we know supplementary is going to add to 180 degrees. So if they're congruent, we just set them equal to one another, we divide both sides by 3, we get x equals 40. If they were supplementary, we might do something like this. Let's say I told you that it was 3x and it was 2x. Okay? And let's say we were going to solve for x in order to figure out how big each of those are. All right? So these measurements will be a little different than the ones we previously got, but it's the same idea. We look at the angle relationship. Well, we have 2 angles. They're on the same side of a straight line, and they share the same vertex. They're adjacent to one another. That's going to make them a linear pair. So I know that if I take these 2 angles and I add them together, I'm going to get 180. So here's one of the angles, 3x. And I'm going to add it to the other angle, 2x. And that's going to equal 180. Well, 3x plus 2x is going to be 5x. So we're going to get 5x equals 180. We just combined like terms. Now all we have to do is solve. So we divide both sides by 5. Because remember, whatever we do to one side, we have to do to the other. And in order to get rid of something we don't want, we have to do the opposite operation. So we divide it by 5 to cancel these out. And then whatever we do to one side, we do to the other. We get x equals 36. And then that's our answer. So I would know x equals 36. I can then plug it in to figure out how big the rest of these are. I could multiply 36 by 2 and get 72. I can multiply 36 by 3 and get 108. And if you do 72 plus 108, you'll see they still add up to 180 degrees, and that's all there is to it. So those are the angle relationships. Make sure you get all this down. Everything that's up here, if you haven't taken notes yet, make sure you get them. I'm sure this video will replay at some point. You can watch it then. If you get stuck, keep watching it until you do get it. If you're still really stuck, I should be around after school. I've either come by to let you know when, or I'll be coming by soon. If I've already come by, ask somebody. I'm sure they'll let you know when I'll be around. The next time you see me, though, outside of extra help, it'll be in person. I should be back. So until then, best of luck, and I'll see you later.